Hi, in this video we will keep talking on section 7.3 and wanna focus on the problem type a squared plus x squared. And we basically hear the second problem type in this section. And when you get the problem, you surely want to find something related to a squared and x squared. But the relationship here is a squared plus x squared. Or surely x squared plus a squared, they're the same thing, right? Okay, so when you see this, you understand x equals a times tangent theta. We want to make sure here is a single x, but if here x multiply a constant, we want to rewrite it in another way, which mentioned in the previous video. So here x equals a tangent theta, and then your square root a squared plus x squared gonna equals a squared plus a squared tangent theta squared, and take the a squared out, 1 plus tangent theta squared square root. This part is secant theta squared, so after getting rid of the square root, you get a by secant theta. Okay, so that is how we apply the substitution and get rid of the square root. And also dx gonna be, since your x you already set it equals a tangent theta, dx gonna be a secant theta squared d theta, derivative of the tangent theta. And sometimes there is no square root in the problem. Say for example you say integration a squared plus x squared, and of course they're gonna be powered, for example 2, or divide by something, multiply something outside, multiply something, numbers or function. Again, we want to focus on the format that a squared plus x squared, something looks like this, and apply the substitution. What is outside, we just don't really care. We just simply substitute. Later, they're gonna be cancelled or solved by formulas, so that's not the point. Okay. And also, we want to remember this too. And we don't want data in our answer. So if the answer with something about data, we want to surely change everything expressed back into x. But if it is a constant, for example pi over 4, it is fine. We don't need to change anything back. And to change data back into x, we need to use our triangle method, which also mentioned in the last video. And the second one is if the integration is a limited one, we surely want to change limit. Don't forget that. Let's see the problem. Okay. After I get this problem, I find okay, something squared plus a constant, right? Okay. I know that a squared plus x squared, I set x equals a tangent theta. But here is a single x equals a tangent theta. So I want to rewrite it into integral dx over square root 16 plus 2x squared, right? It's 4x squared. And then in this case, 2x is simply my x here, right? For this single x. So 2x is equals 4 tangent theta. because a is 4 square here. So I solve for x equals 2 tangent theta. Dx is 2 secant theta square d theta. Okay, and then plug in integration 2 secant theta square d theta, which is what on top, square root 16 plus 2x square, which is here 16 tangent theta square, and this equals 2 secant theta square d theta, and then simply it's 4 secant theta. Okay, so for this part, take 16 out plus 1 plus multiply 1 plus tangent theta square root, right? I'm doing this, which equals 4 by square root secant theta square, right? This is secant square, and then 4 secant theta. So that is how it works, and I can simplify it. 1/2 take the constant out, secant theta d theta. Okay. In previous video, I showed you how to solve the integration of the secant theta. So here I just simply apply the answer, which is 1/2 natural log absolute value secant theta plus tangent theta, and plus c, because there is no limit for my integration, right? Here, no limit. Okay. If you couldn't remember how this comes, you probably want to go back see the video secant and tangent only, the integration, that video. And okay, I find my answer including data, which is improper. I want to change back into x. What I need to do is go back to the very beginning, find the relationship I set up between x and the data, which is here. Okay, x equals 2 tangent theta, which indicates tangent theta is x over 2. Draw that triangle. That is our triangle method. Right angle theta here, and tangent theta is this side over this side, right? X over 2. Okay, and then the third side is 4 plus x squared. Okay, so I need tangent theta is already known, which is x over 2. I need secant theta. Secant theta is 1 over cosine theta. Cosine theta is this side over this side, right? So that is 2 over square root 4 plus x squared. That is cosine theta, and the whole thing divided by 1, which is flipping it over 4 plus x squared over 2. Okay, and then I plug in. Here. 1/2 natural log absolute value secant theta square root 4 plus x squared over 2 plus tangent theta x over 2 absolute value plus c. So this is my final answer here. Okay, so for this problem, we want to know how to apply substitution, how to set it up, and also again, if x is not a single x squared here, if multiply something constant outside, we still can solve it, right? So set what is under the square equals a tangent theta. and then apply substitution triangle method to find the answer. Let's see the next one. Okay, let's see this one. After I getting this problem, I find there is no square root, but as we mentioned, it's fine. What we really want to focus on is the format x squared plus a squared, right? Or a squared plus x squared. We are looking for this format, which is here, and so I can set up substitution. The second part I noticed is here is a limited integral, which indicates I gonna need to change limit, right? So set up a substitution. X equals a times tangent theta, which is 6 tangent theta here. Dx is 6 secant theta squared d theta. Okay, so since x is greater than 6, less equal than 6 square root 3. So 6 tangent theta greater or equal than 6, less equal than 6 square root 3. Plug in x, right? Because x is equal to this. Solve for this. Cancel out the 6, which is tangent theta greater than 1, less equal than square root 3. Okay. Remember these two triangles with special angle pi over 6 and pi over 3. And this one, pi over 4 triangle. Okay. 1, 2 square root 3. 1, 1 square root 2. Okay. So we have to be very familiar with these two triangles. So I find tangent equals 1. If tangent theta equals 1, goes to here. This side over this side, right? For angle is pi over 4. Less equal than theta. Less equal than for tangent theta equals square root 3, which is this side over this side, goes to pi over 3. So I find my limit for theta, which is my new variable here. What is following d, right? The new variable, plug in. So my question rewrite into pi over 3, pi over 4. Copy. Again, since we said we only care the format, which is finding here, what is outside, I simply apply my substitution. Later I'm gonna cancel or solve by formula, so it doesn't matter. Plug in x squared 36 tangent theta squared, which is here, right, from the very beginning. What is here is 36 tangent theta squared plus 36 square it, and then by dx 6 secant theta squared d theta here. Okay, try to solve this part out and see what can be cancelled. Pi over 3, pi over 4, 36 tangent theta squared. Okay, I want to write one more step. I take the 36 out, tangent theta squared plus 1, square it by 6 secant theta squared d theta. Okay, so pi over 3, pi over 4, 36 tangent theta squared, and the 36 squared here is secant squared, so square it gonna be secant theta to the 4th. A multiply 6 secant theta squared d theta. Okay, so let me see. This 36 can be cancelled out with 136 here, and the 6 can cancel out with a 6 left, And the secant square here is cancelled out with secant square left. Okay, looks fine, and rewrite it. I take the constant out, which is 1 over 6, pi over 3, pi over 4, tangent data square over secant data square d data. Okay. And then I find if I use substitution, it doesn't work here. I need to rewrite it. So 1 over 6, pi over 3, pi over 4, tangent data square, which is sine data square over cosine data square, right? Sine over cosine, square it. And we know that secant data is 1 over cosine, right? Secant equals 1 over cosine. So if I divide the secant square, here is a multiply cosine data square. Copy the data. So it's clear here can be cancelled. What is left is I move to here. 1 over 6, pi over 3, pi over 4, sine data square d data. Okay. Integration with sine, cosine with even powered. We mentioned in the previous video. You can go back and check. Remember the key formula here. If the even power here, we always want to use sine data square equals 1 minus cosine 2 data over 2, right? This is our key formula. So plug in equals 1 over 6, pi over 3, pi over 4, 2, 1 minus cosine 2 data d data. Okay, so what I need to do is I want to take the constant out with this 1 over 6 and split it into two integrals, right? 1 minus the left part, so 1 over 12. Integration pi over 3, pi over 4, 1 d data minus from, 3 here, pi over 3 and pi over 4, a cosine 2 data, d data. Okay. So I surely can solve it. 1 over 12 data from pi over 3, pi over 4, that's my limit, minus 1/2 sine 2 data from pi over 3, pi over 4. Okay, so what I need to do is simply plug in the angles to find the answer. So 1 over 12. Here, pi over 3 minus pi over 4, right? If I plug in these two into data, so I simply get pi over 12 minus 1/2. Okay, sine 2 data. So if I plug in pi over 3, that's gonna be sine 2 pi over 3, right? That is, if I plug in this number. So sine 2 pi over 3 is square root 3 over 2 minus plug in pi over 4 in, which is sine 2 pi over 4. 2 data, right? What is here is sine pi over 2, which is 1. You can simplify it. And then, yes, in this way. So if I want to simplify it, I got pi over 144 minus square root 3 over 48 plus 1 over 24. Okay. So that is my answer, this part. Okay. And I need to check if there is a data in. there is no not, right? All of them are constant, so I don't need to use triangle method to find x. This is fine. My answer is okay. And again, if there is no square root, that is surely fine. And what is out? There are something outside. It doesn't matter as well. What I need to do is find the format, which is a square and x square, apply substitution. Okay, let's see next one. Okay, let's see this one. Again, I didn't find any square root, but what I really care is the format here. A square plus x square, which this one. And then again, this problem similarly something outside my format, but I don't care of it for now. I only set up my substitution first. So x equals simply tangent theta, right? A tangent theta, which is 1 here. Dx is secant theta square d theta. Plug in. And I find there is no limit, so I don't need to change limit. So tangent theta to the fourth over 1 plus tangent theta square by secant theta square d theta, which is copy. Okay, so that is tangent theta to the fourth, solving for here, secant theta square by secant theta square d theta, which is very clear. These two can be cancelled out. What is left in is tangent theta to the fourth d theta. Okay, so this is integration with tangent only. We should know which key formula we are using. I have previous video that introduced integration of the secant only and the tangent only, which including this problem. So let's see here. I remember I want to separate it into tangent square by tangent square here, d theta. Rewrite tangent square into secant theta square minus 1 d theta. And then I need to separate it out, which is tangent theta square secant theta square a d theta minus tangent theta square d theta. I multiply the tangent square in and split it. So for this part, it's since I see this, u substitution, u equals tangent theta. Then du is secant theta square d theta. Okay. Plug in. So my first part is u square du, right? And then minus second part here, rewrite it into secant theta square minus 1 d theta. Okay. So move to here. This is equals 1/3 u cube minus, okay, integration secant theta square d theta minus 1 d theta. Separate it out, which is 1/3 u cube minus, okay, this is simply tangent theta minus theta plus c, because no limit, right? So 1/3 u is tangent theta, which set up here. Go back, tangent theta cube minus tangent theta plus c. Okay. So So far I get here, and I find here is the data. I don't want them. I want to change into x. Go back to the very beginning to find the substitution I set to find the relationship, and it's very lucky here because the relationship we set up is tangent data, and the answer is also about tangent data and other data. So probably I don't need the triangle method, just a plug in 1/3 x cubed, which is x minus x tangent data, plus what is data? Just simply arc tangent x, right? Implies data, and then plus c. Okay. Sometimes it's lucky because you find you just can directly plug in, but it's not always true. We surely should know how to use the triangle method. So, but for this problem, I'm fine with here. This is my answer. Okay. Again, a brief summary for this part. The format we are looking for is a squared plus x squared, constant plus x, something with x squared. It can be single x here or a squared plus, for example, 4x squared. It also works. I just said 4x equals my a tangent data. That's fine. And then solve for x. It doesn't matter. And there can be square root or no square root divided by 1 or multiply something outside, or if there is no square root, it can be powered with 2. It doesn't matter. What we focused on is finding the format and set up our substitution. For the what's outside, you just plug in your substitution. You surely later can find formula or cancel something out. So this is our key part. Again, triangle method, how to set it up. You can find the method in the last video, which I already mentioned. And the 3 is if there is a limit, we surely want to change limit by using substitution. So here, limits should always apply to the corresponding variable, which is what you following D, right? If data following D, your variable now is data, but if it's x, your variable is for x. So same for the limit, okay? Okay. So that's all about this problem tab, and wish this helps again, and thank you for watching. See you in my next video. Bye bye.